Good morning. Today we are starting chapter 10, that is your mechanical properties of a fluid. In this, first we have to study about the fluid mechanics. Fluid mechanics. Now, fluid mechanics means what? It is a branch of the physics which deals with the study of the fluid. It is a branch of physics which deals with the study of fluids. In the fluids, just we are considering liquids and gases. Liquids and gases. Either they may be at a rest point or in motion. Fluid mechanics can be defined as it is a branch of physics which deals with the study of the fluid. Fluid means we are including liquid and gases. That liquid and gases or a fluid, it should be in a rest point or in the motion. If it is at a rest point or in motion, then we can call it as what? Fluid mechanics. This fluid mechanics is divided into two types. First one, hydrostatic. Another one is hydrodynamics. The fluid mechanics is divided into two types. First one is hydrostatic and another one is hydrodynamic. Now next we have to study about the hydrostatic. Hydrostatic. Next here we are telling it is a branch of the fluid. It is a branch of the fluid which deals with the study of the fluid should be at a rest point. Fluid should be at a rest point. Then we can call it as hydrostatic. Hydrostatic is what? It is the branch of the fluid mechanics which deals with the study of the fluid. The fluid should be at a rest point. Then we can call it hydrostatic. Here rest point means it is at a constant point. It is not moving. If it is not moving, it is at a constant point, then we can call it as a rest point. Now next one is hydrodynamic. Hydrodynamics means what? It is a branch of the fluid mechanics which deals with the study of the fluid at a motion. At a motion point or at a motion, then we can call it as hydrodynamics. Here first one is fluid mechanics. It is a branch of the physics which deals with the study of the fluids at a rest or the motion. At a rest or the motion, just we are considering one is liquid and the gases. Next, this fluid mechanics is divided into two types. One is hydrostatic and another one is hydrodynamic. Hydrostatic means what? It is a branch of the fluid mechanics which deals with the study of the fluid at a rest point, then we can call it as hydrostatic. Hydrodynamics means what? It is a branch of the fluid mechanics which deals with the fluid at the motion point, then we can call it as hydrodynamics. This fluid came from the Latin word. This fluid came from the Latin word. In the Latin word, fluid means what? To flow. To flow. Fluid means what? To flow. If the substances are flowing, then we can call it as what? Fluid. To flow means we are giving one example, that is what? Water. Example we are giving as the water. Okay, fluid means what? To flow. Now next here we have to consider the definition of the fluid. Fluid means the substances which can flow is called as the fluid. Next, here only we are considering one is perfect liquid or ideal liquid. Ideal liquid. Next one we have to study about the perfect liquid or the ideal liquid. Here it should be in a non-viscous. The fluid is in a non-viscous. The fluid should be in a non-viscous. If it is non-viscous, then we can call it as perfect liquid or the ideal liquid. Now again one more is there, perfect fluid or ideal fluid. Or ideal fluid. Here we are considering the fluid should be in non non-compressible and non-viscous. Non-compressible and non-viscous. Then we can tell it has perfect fluid or the ideal fluid. Fluid means to flow the substances, either it may be a liquid or a gas. Next one, perfect liquid or ideal liquid. It should be in a non-viscous state. Next one, perfect fluid or the ideal fluid. It should be in a non-compressible and non-viscous state. Then we can call it as a perfect fluid. Next, we have to study about here thrust. Next, we are studying about the thrust or a fluid thrust. Fluid thrust. Now, fluid thrust means what we have to know here. The total normal force which is exerted on a body. The total normal force which is exerted on a body, then we can call it as fluid thrust. Next one is fluid pressure or a pressure. Fluid pressure or a pressure. Pressure. To define the pressure, just we have to consider this pressure is depend upon your fluid thrust. Next, we can tell that pressure is equal to, we are writing thrust by the area. Thrust by the area. Therefore, fluid pressure can be defined as what? Thrust by the area. Or this thrust is equal to the force. Force by area. The other name of the thrust is force. We are considering as a force. We can call it as a force or a thrust. Now, therefore, the liquid pressure can be defined as the thrust by area, or it is also equal to the force by area. Now, next, the dimension formula. Or first, we have to study about the SI unit of your pressure. The SI unit of the pressure is Newton per meter square. The SI unit of the pressure is Newton per meter square. How we are getting the Newton per meter square? We know that the SI unit of the force is Newton. Area we are considering meter square. Therefore, total the SI unit of the pressure is Newton per meter square. Newton per meter square. Or it can be also written as Nm raised to -2. Or again one more unit is there, that is Pascal. It can be denoted as capital P, small a. The SI unit of the pressure is Newton per meter square or Pascal, and it can be denoted as capital P, small a. Now the dimensional formula for the pressure is, we have to write in the square bracket, that is L raised to -1, T raised to -2. It is the dimensional formula for your pressure. L raised to -1, T raised to -2. And you can tell that pressure is a scalar quantity. Pressure is a scalar quantity. Now we know that 1 bar is equal to, we are considering 10 raised to 5 Pascal. 1 bar is equal to, we are considering 10 raised to 5 Pascal. And it can be also written as 1 atmospheric is equal to, we are writing 1.013 into 10 raised to 5 Pascal. The value of 1 atmospheric is equal to 1.013 into 10 raised to 5 Pascal. Or this can be also written in the form of 1.013 into 10 raised to 5 there in Pascal, or this can be converted as 101.3 into 10 raised to 3 Pascal. This 10 raised to 3 can be also written as 101.3 into kilopascal. Total answer for the 1 atmospheric is equal to, we are getting 101.3 kilopascal. This is for the 1 atmospheric pressure. We are getting the answer at this much. This is just about your pressure. Now let us consider the expression for liquid pressure. Now let us see the diagram. Here we are considering a vessel. In that vessel there is a water. For up to here there is a water. Up to this we are considering the height. And the outside we are containing the area of the cross section of a body. Now let us consider here, we know that pressure is equal to, now just we have taken that thrust by area or the force by area. The formula for the pressure is equal to what we have taken, force by area. Now in this case, if you know the formula, we can write this as P is equal to F by A. That is your pressure. Now we know that F is equal to what we can write, mass into gravity. F is equal to, we know that, mass into gravity. Now this pressure can be also written as P is equal to mg by A. But we know that M is equal to, but we are considering mass is equal to rho into V. Rho into V. Now let us consider this equation, M is equal to rho into V. Now let us take this as, consider this equation as 1. Next we are considering P is equal to, just put the value mg by A. Now we know that M is equal to rho into V. Now put this rho into V into G by area. This is in the case of the mass we have taken P is equal to rho Vg by A. Rho means liquid density, V means it is the value, G means acceleration due to gravity, A means area of the cross section of a body. Now let us consider this as equation 3. Now again we know that density is equal to, but density, or we can also know that volume is equal to, we know that volume is equal to, we are considering area into height. Area into height. This can be written as A into H. Now consider this as equation 4. Put equation 4 in equation 3. Put equation 4 in equation 3. Next we are getting P is equal to rho A parity. V means what is there? A into H. A into H into G by capital A. Area get cancelled. Then the remaining answer, P is equal to rho H G. Pressure is equal to, we are getting rho H G. This we can call it as a paradox equation. Now next we know that P is equal to what we are getting, rho H G. Now we are considering the total pressure which is applying on a body, PT. This is the total pressure which is applying on the liquid pressure of a body, is always equal to the atmospheric pressure. PA means atmospheric pressure plus rho Hg. It is a paradox equation. Rho P is equal to rho Hg. We are calling it as what? Paradox equation. Therefore, the total pressure on a liquid is equal to the atmospheric pressure plus the paradox equation. This is the equation for your liquid pressure. Now next we have to study the gauge pressure. Gauge pressure can be defined as the pressure in a liquid at a point. The pressure in a liquid at a point and atmospheric pressure. And atmospheric pressure. Is called as gauge pressure. Gauge pressure means what? The pressure in a liquid at a point and the atmospheric pressure is called as gauge pressure. And last one we have to study here, liquid pressure. Liquid pressure. This liquid pressure is equal to gauge pressure. Gauge pressure. It depends upon your gauge pressure. Liquid pressure is equal to the gauge pressure, or this can be also written as PL is equal to. PL means what? It is the liquid pressure is equal to the PT minus PA. PT means what? It is the pressure point in a liquid at a point, and PA means what? It is the atmospheric pressure. In the case of the and, we are considering the minus sign. This is just about your liquid pressure. Liquid pressure is depend upon your gauge pressure.